Well, hello everybody, this is Mr. Bauer, and today we are going to start talking about trigonometry. And more specifically, we're going to start talking about the trigonometric ratios, right? Or trig ratios as we call them sometimes. We shorten that word, trigonometry. What are the trig ratios? Well, there's three words that we're going to be introducing to you today. They are the sine, the cosine, and the tangent. And they are indeed ratios. That means they're fractions. That means we're going to be able to take two numbers and make a fraction out of them, or a ratio. And first of all, maybe just a little bit of history on trigonometry. Did you know that trigonometry is based on the properties of similar right triangles? Okay? Don't know if you knew that or not. Did you know that the word trigonometry comes from two Greek words meaning triangle measurement? All right, so when we talk about trig, we really want to start thinking about right triangles and triangle measurement. All right, the sine, the cosine, and the tangent. Now let's look at some other vocabulary that we're going to have to use. All right, do you see the right triangle here? Do you see B is the right angle, and we have angle A, and we have angle C? Well, let's see what important points we have here. In order to understand trig, you'll need to be able to create a ratio of two sides. Okay? Maybe there'll be numbers here, like a 12 and a 13 and a 5. Maybe they'll just be letters, like this is side BC and this is side AB, and we'll make a ratio of two of those sides. That's just kind of the basics of it. You'll need to be able to use the words opposite and adjacent in order to create the correct ratios. So we're going to add two new vocabulary words here. Opposite, which you know that word, we've used it before, and adjacent. Adjacent means next to. We're going to have to use those in order to create the correct ratios. Let's see what the third thing here says. It says, well, the words opposite and adjacent all depend on what angle we're referring to in the problem. If I look at angle A, okay, this is angle A right here. What side is opposite? Well, it would be BC here, or CB. That would be the side that's opposite that angle. What would be the adjacent side to angle A? Well, it would be AB. That is adjacent or next to the angle. Why didn't I choose AC for the adjacent side? It's next to it, isn't it? Well, because that's the hypotenuse of the right triangle, and the hypotenuse is always the hypotenuse. So as we get into this, we're going to look at an angle. We're going to start looking at the side that's adjacent to that angle, the side that is opposite that angle, and the side that is the hypotenuse in that triangle. And from those three sides, we'll be able to pick two of them and make us a nice, neat ratio. Okay? So that's a little bit of just basic understanding. Let's see how we actually do it now. I guess we probably need to create some definitions for what the sine is, what the cosine is, and what the tangent is. Well, the sine of an angle is created by putting the opposite side over the hypotenuse. So back here, if we were going to try to do the sine of A, all right, here's angle A. What is opposite that? Well, isn't CB or BC the opposite side? And what is the hypotenuse? Well, isn't that AC? All right, so that would be our ratio. All right, we used the names of the sides to make it. As we progress through this chapter, you'll start to use numbers. They'll mark numbers on here, and you'll put those in there. All right, the cosine is not opposite over hypotenuse. It's adjacent over hypotenuse. So if you were going to go up here, instead of using BC, you would use AB as the adjacent side and still AC as the hypotenuse. The tangent of an angle is made by putting the opposite side over the hypotenuse. So if we're looking at angle A, opposite BC over adjacent AB. All right? There's a way that I remember these, and I'll see if I can spell it out. I tell a story. That's not it at all. I tell a story in some of my classes about the great Indian chief, Chief Sokotoa. Chief Sokotoa. And he's not really an Indian chief. It's really just a way to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right? So if you can remember those, then you can set up the trig ratios from any triangle that you have. All right? You need to know where the opposite side is, you need to know where the adjacent side is, and you need to know where the hypotenuse is. All right? Let's do a couple of examples here. All right? Here's a triangle. It's a right triangle. And we want to find the sine of angle R, the cosine of R, the tangent of R. So I guess that means we're looking at R here. Okay? All right. What did we just learn? We're looking at Chief Sokotoa. And the sine is a ratio of the opposite over the hypotenuse. So here's side R. What's the length of the opposite side? Oh, it's got to be over there, doesn't it? So it would be 5. All right? Hypotenuse. What's the hypotenuse of this triangle? That would be 13. All right? Very good. What about the cosine of R? Well, cosine is not opposite over hypotenuse. It's adjacent over hypotenuse. Do you see how the 12 is the adjacent side? Adjacent over hypotenuse. Here's the adjacent to R, and there's the hypotenuse still. The tangent is what? Opposite over adjacent, 5 over 12. Okay? 5 over 12. Now, one way to write these is to leave them as fractions. Okay? Sometimes those are perfectly acceptable answers. Sometimes you'll be asked to write them as decimals. So how do we handle 5/13 as a decimal? Well, we simply go 5 divided by 13. It equals that. Let's round it off to 4 decimal places. 3, 8, 4, 6. The 1 tells the 6 to say the same. So 3, 8, 4, 6. The sine of angle R is either 5/13 or 0.3846. What about the cosine of R? Well, that would be 12 divided by 13. 92307. The 7 tells the 0 to become a 1. 0.9231. Okay? Same thing with the tangent. If we were going to do this, we would go 5 divided by 12. 0.41666. Doesn't this 6 tell that 6 to become a 7? Yes, it does. 0.4167. All right? So finding the sine, the cosine, and the tangent involves looking at the triangle and determining what's the adjacent side, what's the opposite side, what's the hypotenuse. All right? Now, out of this same triangle, instead of looking at angle R, we could look at angle T. All right? Well, let's do that. Let's get rid of this so we don't confuse ourselves. And instead of looking at angle R, let's look at angle T. All right? If this is angle T, which side is opposite? Well, 12 is opposite, isn't it? Mm-hmm. What side is adjacent? Well, I think the 5 is the adjacent side. And guess what? The 13 is still the hypotenuse. So the sine is opposite over hypotenuse. That would be 12 over 13. Hey, wait a second. The cosine of r was 12 over 13. Well, yep, we're going to have some repeats now. Okay? What about the cosine of t? Cosine is adjacent over hypotenuse. That's 5 over 13. Hey, the sine and the cosine, they just switched around, didn't they? It's probably going to happen anytime you're dealing with two angles in the same triangle. And finally, the tangent of angle T is going to be opposite over opposite over adjacent. And that was exactly the reciprocal of what the tangent was there. All right, you can change those to decimals, you can leave them as fractions, depends on what the directions ask you to do. That's how we find our trig ratios. All right, we got to remember Chief SOHCAHTOA, and then we've got to be able to look at a triangle and determine what's our opposite side, what's our adjacent side, what's our hypotenuse. All right, good luck.